Hi, I'm Elizabeth Black, the organizer of the Citizen Science Soil Health Project, which is a 10-year-long project to help growers prove that they are improving their soil. 44 Boulder, Weld, and Larimer County growers are currently enrolled in the project, which is sponsored by many local organizations and the USDA. We offer each grower one free soil health test every year for the 10 years of the project. Growers can buy extra tests too whenever they want. Growers gather their own soil samples. I send the samples into the lab, track the results, and pass the results on to our growers. We use the Haney and PLFA tests from Regen Ag Lab to assess soil health. The Haney test gives each grower a soil health score, which is based on this complicated formula. If we translate Haney's complicated formula into regular English, it turns into this. Haney's soil health score equals the number of microbes in your soil plus the amount of carbon-rich food they have to eat plus the amount of nitrogen they can supply to other living things. So a soil with a high soil health score has lots of soil microbes, lots of carbon-rich organic matter for soil microbes to eat, and supplies living things with lots of nitrogen to make the building blocks of life like DNA and proteins. The first problem we ran into when we were building our project is that the Haney test is not real user-friendly. The results you get back from the lab are just a bunch of difficult-to-interpret numbers. We had to make the data understandable for our growers, so we developed a handy-dandy, user-friendly report that uses color coding to let growers know which values to be concerned about, and includes normal ranges and explanations about each value. We also provide all our growers with a confidential year-end report that shows them how they are doing compared to their peers. This slide shows the report format. This particular grower tested 2 sites. The 2 colored columns on the left show the grower his results for 6 important soil health indicators. The 3 columns on the right show him how his peers did with the maximum, minimum, and median value for all 6 soil health indicators. So this grower can see that he is doing pretty well and is staying right in the middle of the pack. These comparisons will encourage all our growers to adopt more soil health practices. Our growers are a very diverse bunch, and no one solution fits them all. They have all committed to raising their soil health scores in whatever way they think will work best for their operation. We do not tell them how to do it. We are a grower-driven project, and our growers have centuries of farming experience between them. They are the best judges of what will improve their own soil's health. Our growers all meet once a year for dinner in a class on soil health. Our recent class with Lance Gunderson on interpreting soil health tests can be viewed on the Boulder Valley and Longmont Conservation District's website. So progress to date. Our 2019 data from 96 sites is all analyzed and reported. Our 2020 data from 130 sites is still dribbling in and will be analyzed this winter. Here's what we've found so far. First, there is a huge range of soil health scores across the county. This graph shows 2019 soil health scores ranked from a low of 3 to a high of 36. The red line in the middle represents the median score of 14, which means that half the samples have scores above this and half have scores below. The red circle is at 18, and scores over 18 are rare in Colorado, so we should be proud of our high scorers. This graph shows that there's lots of upside potential for some of our lower scoring fields. We also examined pH because the Front Range is known for its alkaline soils. And no surprise, most of our sites are alkaline, with about half in the concerning range. Our high pH is partly why soil microbes have a much harder time in Colorado, and why improving our soil's health takes longer here than in other parts of the country. Next, we looked at organic versus conventional growing methods. We divided our 96 sites into 3 groups: conventional, organic, and non-farm. Non-farm sites are where no crop is grown, like abandoned, uncultivated farm fields, grasslands, and forests. And this is what we found. The red bars here are sites using conventional growing methods. The yellow bars are organic sites, and the green bars are non-farm sites. As you can see, there is not really a clear pattern here. It's sort of a mishmash. Then when we look at the median scores on this next graph, you can see that the big red and yellow arrows are the median scores of our conventional and organic growers and are essentially the same, 13 something. The big green arrow is the median score of our non-farm sites and is much higher, 21. So organic or conventional methods do not seem to make a significant difference for soil health. But what is going on here? Why is the non-farm group doing so much better? Well, we looked at tillage next and got the answer. We divided our 96 sites into 3 groups: zero tillage, reduced tillage, and conventional tillage. Our zero tillage sites included irrigated pastures, grasslands, and forests. Reduced tillage sites included strip till with herbicides, small garden plots using hand tools, and chisel plowing, which disturbs the soil less. Conventionally tilled sites included growers who used rototilling, moldboard plows, and lots of mechanical cultivation. So this graph shows our findings. Here the red bars are conventionally tilled sites. The yellow bars are reduced tilled sites, and the green bars are the zero-tilled sites. You can start to see a pattern emerging in the rainbow of colors, with the red bars more at the bottom end and the green bars more at the top end of the graph. And the median scores in this next graph confirm what your eyes see. Our zero-tillage sites totally rock out, with a median soil health score of 20, right where the big green arrow is. The big yellow arrow shows the median for our reduced tillage sites, and the big red arrow at the bottom shows the median soil health score for our conventionally tilled sites. So tillage intensity has a clear effect on soil health. This is why our non-farm sites have higher soil health scores. It's because they aren't tilled. Next, we looked at water's effect on soil health. We found that irrigated sites all had higher medians than the dryland sites in their same tillage category. So conventionally tilled irrigated land had a higher median score than conventionally tilled dry land. The same was true for reduced tillage and zero tillage sites. So supplemental irrigation water will improve our arid land soil health. Finally, we looked at phosphorus. In this graph, phosphorus levels for non-farm sites are the green bars and are generally very low. Phosphorus levels for conventional growers are the red bars and cluster more around the ideal range. Phosphorus levels for our organic growers are the yellow bars and are generally quite high, up into the concerning range. Phosphorus is a Goldilocks kind of nutrient. You don't want too much or too little. You want it just right. Plants need it to grow, but too much can pollute downstream waterways and cause plant nutrient deficiencies. Manure is a go-to fertilizer for our Front Range growers, and because organic farmers cannot use chemical fertilizer, they often apply large amounts of manure to boost their nitrogen levels. However, manure is also rich in phosphorus, which can build up in soils over time. We found that a number of our organic growers now have excessive levels of phosphorus in their soils. These growers are advised to switch to low phosphorus amendments, use more legume cover crops to boost nitrogen but not phosphorus, and plant buffer strips along the fields to absorb nutrient runoff. I hope our findings help inform your own approach to your own soil's health. If you are interested in joining the Citizen Science Soil Health Project, please get in touch. We especially want to sign up more conventional growers. Thank you very much for your interest in our project. Bye-bye.